Alright, so what we're going to work on is simplifying algebraic expressions. And when we simplify algebraic expressions, we're actually doing something called deductive reasoning. Deductive reasoning, just fancy words for using facts to support why we're allowed to do something. We're not allowed to add variables together just because we want to. We have to have a reason. So a definition of deductive reasoning is the process of reasoning logically from given facts to a conclusion. So we're going to be given information, in this case algebraic expressions, and we're going to be able to simplify down and conclude here is our answer. Now that sounds a little bit confusing, but let's start with something that makes a little sense to us. First up, simplifying this. Notice this isn't an algebraic expression, this is a numerical expression. And there's a couple ways to do this. We'll start with the easiest one, the one that you're all good at, and that's using the order of operations. The order of operations says look for work in the parentheses. Here's parentheses, but there's no work in there. Those parentheses are separating the 4 and the 2 to say multiply. Here's another set of parentheses, and there is work to do in there, so we would do the 3 plus 2 first to get 5. Bring down the 3 and everything else. So first we worked in parentheses, or we worked in grouping symbols. Then we look for exponents, and there are none. Multiply and divide from left to right. So when I go left to right here, the 4 next to the 2 separated by parentheses means multiply. Bring everything else down. Let's see, we worked in grouping symbols, we looked for exponents, we're on multiply and divide left to right. There's more multiplying to do. The 3 and the 5 are next to each other with parentheses separating them means multiply. Bring everything else down. No more multiplying or dividing left to right. Add and subtract left to right. We finish with 23. That's the way most of us would do that problem. It's correct, it's very efficient, it works very well, but I would like to explain that there is another option for us. I'll just rewrite the problem real quick. 4 times 2 plus 3 parentheses 3 plus 2. Now, we know that parentheses mean groups of. This is 4 groups of 2 plus 3 groups of 3 plus 2. We've also learned that the distributive property is a form of multiplication. I could distribute this 3 to the 3 and the 2 inside parentheses. And what it would say is that I still have 4 groups of 2 plus 3 groups of 3 plus 3 groups of 2. Now I know most of you would never solve this problem this way, but if you hang with me, you're going to see why I did this. I want to prove to you that this is just another way. And I'm actually using deductive reasoning. I'm explaining why mathematically it's okay to do this. It was okay because we distributed. Now, when we've talked about combining like terms previously, like terms, hey, 4 groups of 2 and 3 groups of 2. This is all addition. You'll notice there's addition here and addition here. And we know the commutative property of addition says it's okay to switch things around. So I'm going to take this term, the 3 groups of 2, and this term, the 3 groups of 3, and switch them because the commutative property of addition says I can do that. Now it says I have 4 groups of 2 plus 3 groups of 2 plus 3 groups of 3. Well, combining like terms, 4 groups of 2 plus 3 groups of 2 is 7 groups of 2 plus 3 groups of 3. Well, basic math, 7 groups of 2 is 14. 3 groups of 3 is 9, and 14 plus 9 gives us 23. We got the exact same answer, 2 different ways. Like I said, most of you would do the order of operations and you'd be done faster, and that's fine. Remember what I said? Hang with me, you'll see why I did it the second way. Because now we have an algebraic expression. And this algebraic expression, I'd love to do the order of operations. First thing in the order of operations says work inside grouping symbols. But I can't work inside those grouping symbols. 3 plus g, I don't know what g is. So I can't add them together. I can't add 3 plus g and get something. So that means I need to go with another method here. Okay? Working in parentheses, looking for exponents, neither of those work. But multiply and divide left to right still works as I go through the order of operations. Distributive property is a form of multiplication, so I can distribute this. I haven't done anything with the 4g, so I'm going to bring that down. Plus, when I distribute 3 groups of 3, 3 groups of 3 is actually 9. Plus 3 groups of g, well that's 3g, 3 groups of g. So justify each step. Justify each step like it says right here. We don't have to write sentences to justify it. I'm just explaining. Showing your work is another good way of explaining. Justify each step. I distributed. I used the distributive property. So I'm not just doing something crazy. I'm actually using mathematical logic here. I'm going to look for like terms. 4g and 3g are like terms. Now I notice that this is all addition. So I can combine the like terms, but I want them next to each other. So we've learned that if there's addition, the commutative property of addition says it's okay to take these and switch them around. So now I have 4g plus 3g plus 9. Combining like terms, the like terms have to have the same variable. 4g plus 3g, 7g plus 9. Now some kids are going to want to go one more step and they're going to want to put that together. They think that says 16g, but that can't work. If I'm combining things to add them together, they have to be like terms. They have to have the same variable. This is like saying 7 goats, 7 groups of something plus 9 not goats because there's no g on it. This is our answer. 7th graders don't like it. It's confusing. They think, what's the answer? That's the answer. That is as simple as that expression can be. So now that we've practiced a little bit, here's one, should be in your notes. You should try it. When you're done, come back to the video and see if we agree. So now's a good time to pause. Alright, hopefully you have tried at least, and maybe you got a very different answer than what I'm going to get, and that's okay. Making mistakes is alright. No big deal to make a mistake, but we need to learn from our mistake and fix our mistake. And the very first thing that some kids forget to do, we've talked about this previously, anytime we have an expression, if there is subtraction, it's going to help you to change it into addition. And to do this, we know that we change subtraction into addition and make this the opposite. So now it's a negative 7y. Stuck like glue. I glued that negative sign onto the 7. And if you say, well, that's not what we normally do. Well, remember, we could glue the minus sign on like that and sneak a little plus in there. It's the exact same thing. You're adding the opposite. So if I rewrite it nice and neat, it says 6y plus 4m plus negative 7y plus m. Another strategy that might help some of you is look at your coefficients. This y at the beginning has a 6 as a coefficient. This has a 4 attached to it. 4 is the coefficient. Negative 7 is the coefficient. There is a coefficient on this m. Okay? Remember, there's an invisible 1 there. The identity property of multiplication says 1 times anything is still that thing. So the invisible 1 is there. So up here where it says justify each step, show your work. Well, I'm showing my work and I'm explaining it to you. First things first, I changed subtraction into addition by adding the opposite, and then I used the identity property. Next, I notice that this is now all addition, and if it's all addition, I can rearrange it any way I want. I want to have the like terms next to each other. So I'm going to move the things that have the variable y to be next to each other. Commutative property of addition. So now it says 6y plus negative 7y plus 4m plus 1m. It's all addition. I can start adding things together. I have 6y's plus negative 7y's. They are like terms. I can add them together. I get negative 1y plus 4m plus 1m. These two terms both have m's. I can combine those. 4m's plus 1m is 5m. So now I have negative 1y plus 5m. Now you got to ask yourself, can I combine those? Can I add them together? This has a y, the first term has a y, the second term has an m. I cannot combine those. If you like to think of real objects, yo-yos and marshmallows. I can't add yo-yos and marshmallows together and have the same thing. So this is actually your answer. Now we've talked about writing our answers in multiple ways. We would accept this for sure. We could also just say negative y plus 5m because we know the 1 is invisible, or you can have it there, but it is negative. So this is acceptable. Some people, because it's addition, would take this first way and rewrite it as 5m plus negative 1y. And the negative 1y could be in parentheses, so there's a way to rewrite it. Let's see, what else could we do? 5m minus 1y, and if you think about it, that's the same as what's above it because plus a negative, so minus 1y is another option, 5m minus 1y. Let's see, I think that's about it. There might be a couple more ways, but those are probably the 4 most common ways you would see this one written. So, simplifying expressions. Important to always know why you can rearrange things or why you can do something. Don't just start putting things together and saying, well, I think that's the way it should go. Think back to everything we've practiced. Make sure you have a logical reason. Good luck today.